Hi everyone, and thank you for joining me for this presentation of the FASTEN project. I will try to give you an overview of what is the project about and explain how we try to improve the dependency management by increasing the accuracy of package manager reports. I'm Antoine Mottier, OW2 CTO, and I will, in this presentation, first start with the current situation of dependency management, what tools we have, what are their limitations, and present the FASTEN project, what is the idea behind the FASTEN project and how it try to improve the current situation. But also I will try to speak and say a few words about the limitations that remain even after this improvement brings by the FASTEN project. But first, let me start with the teams behind this project. So actually, we have a good mix of different contributors to the project. We have some companies, we have universities, and we have non-profit organizations such as OW2. All those participants collaborate to the development of the project. So, what is the current situation? So now when you do software development, when you create a new piece of software, you never create it from scratch. You're always reusing pre-existing component. It can be something low level, such as some feature of the operating system, like, for example, the file system. It can be some features, some libraries coming with the programming language you are using, the standard library. For example, you will not implement again some sorting algorithm. Usually you're reusing pre-existent implementation. And also more and more you are using third-party libraries. And those libraries actually themselves have dependencies on other libraries. So you end up with this kind of graphs where your code have a set of direct dependencies, and those dependencies will have, again, other dependencies. So we'll have what we call transitive dependencies. So for example, here in our example, the dependency TA here is transitive dependency. And you can see some specific situation where you can directly depend on a specific dependencies, but also another few dependencies depend on the same library. And in such situation, it might get you into some trouble because you might require version 1 of the library, but your dependency B might require this version 2 of the library Z here. And so you need to sort it out. You need to pick only one version. For example, in Java, you can only load one version in one given class loader. So there is some decision to be made when we have such conflict. And to help you with that, you have a lot of toolings available. Usually it's specific per languages. So for example, in Java world, the currently probably most popular tooling that can help you with dealing with dependencies is Maven. So these tools will deal with the conflict I exposed in the previous slides, but it also provides some central repositories where it stores and organize all public dependencies, usually open source libraries, and so it takes care for you of downloading the libraries and get them locally on your developer environment or on your continuous integration. You have similar tools with Python. You have pip. For the C programming language, it's a little bit specific, but we can say that the Debian repository, for example, is a kind of central repository, and you have tools like APT that will do the dependency conflict resolution. So you have all those tools that really help you to get your dependency and build the software, but this doesn't prevent you from having this huge complexity. Your software, due to transitive dependency, will have a more and more increasing numbers of dependency, And also on the central server of this package manager solution, like on Maven Central, for example, you have a huge ecosystem of libraries and you don't really have control over them. It's only third-party development. And it raised some issue regarding qualities. For example, what will happen if someone decides to remove the library previously published in a central repositories? And if you rely on this library being available there, it will break your build. So if you are in a continuous development approach, you might no longer be able to deploy. And also, of course, you have this dependency on the quality. The quality of the dependency will impact your application, the overall quality of your application. So usually you carefully select your direct dependencies, but you don't really look into the transitive dependency because it's too much time consuming. So maybe there is this security issue in one of the transitive dependency and it will impact your code. So due to this huge graphs of dependency, it's difficult to do manually search and assessment of quality for each library. So nowadays you have tools that help you with that. For example, you have database of security vulnerabilities such as the CVE. You have automated tools such as Dependabot that can scan your software manifesto and check that your dependency, the version of dependency you are using, doesn't include security vulnerabilities, and they can even automate and working in collaboration with CI to suggest updating the library. But all these tools have some important limitation because they work at package level. So maybe if you have this big library with a lot of feature, you're only using a subpart of the library. So maybe in case of a security issue on the library, it might not impact you because you're only using a subpart of the library. So you don't need to update, even if the tools tell you that you should update because there is a security vulnerability, for example. You probably don't need to update if you are not using this specific part. So the tools really lack this accuracy and leading to false positive. And even new tool, like for example, the recent open source inside from Google, they only work at package level, most of them. So you don't get this accuracy. So you have reports about that includes false positive. And this is really where FASTEN aims to provide a better alternative by bringing this accuracy to reports. So you will provide reports on various aspects of the code. So as stated, security vulnerability, but also license compliance, code quality also, to give you a more precise report. So how it does that? Actually, you can see here above on top what are the approach of dependency manager and what the current tools are doing. They view libraries at package level and they see the dependencies between the various library and the different version. But FASTEN will actually go deeper. It will look inside your code, your application code, to see the function call. So it will build this call graph, and it will do the same for your dependencies and dependencies of dependencies and so on. So it'll give you a very accurate view, the whole call graph of your application. So for example, if there is a security issue in an unused function here, for example, in library 2, it will not tell you to update. And when I say it will not tell you to update, we'll see later, we have integration in package manager with FASTEN. So it's actually the package manager that will report you that. But if the issue is actually on one of the function method called, in this case, of course, it will warn you and provide you guidance with the required update. But generating the code graph is actually only the first step in the processing of the application library codes by FASTEN. Actually, once the code graph of the application and all these dependencies is generated, FASTEN will need to enrich this code graph with extra metadata, such as the non-vulnerability on each individual function, and also licensing information, quality metrics for the code, and so on. So this is really a very important step of FASTEN. Once you got the code graph, it enriched the code graph with a bunch of metadata. So this is an overview of the architecture of FASTEN. So as I said, FASTEN will generate the code graph. For that, you will use the binary version available in public central repositories, the binary version of the library publicly available. But it will actually, to have more accurate code graph, also use the source code and mix the code graph generated from static code analysis and dynamic code analysis together to have the most accurate code graph possible. And it will also do this processing of external source of information, such as CVE, to get the security vulnerability information and associate them with specific code lines and then function in the code graph. And it will also analyze the source code to find out about license, for example, to do some quality metrics. And all that will be stored. FASTEN actually use two different storage, one for the code graph, it's a graph database, and one for the metadata, it's a classic SQL database. With graph database here, because as you can imagine, the volume of data is quite large because we're scanning the whole ecosystem. So on Maven Central, you can imagine there is quite a few libraries now, and with all the method of each library for each version. So the volume of data is quite important. Then from the developer's perspective, how you will work, interact with FASTEN. Actually, most of it will happen through already existing dependency manager tools, such as Maven or pip. They will query FASTEN to get the information, the code graph already generated for the dependencies. Also, part of the code graph generation will happen locally where the dependency manager tool is running. This is for the code of the application that is not yet published, of course, because it's under development. So this analysis, code graph generation, will be done locally and will be merged with the available code graph from the FASTEN server. And then the resolution to find out if a specific, for example, vulnerable function is called is performed locally, and based on the result, this is reported to the user. So maybe it will make the build failed if there is a dependency that is called with a security vulnerability. But if the vulnerability exists in a piece of code that is not called, the build will be successful. So this works, of course, for the developer, but most of the time also it will be really useful when the build is running with the continuous integration server. So that was a very brief overview of the FASTEN project. I guess you might have some questions, so don't hesitate to ask me in the chat or visit the FASTEN website. Of course, I didn't mention it, but FASTEN is an open source project, so any contribution, testing is more than welcome. And this project is actually receiving funding from the European Union as part of Horizon 2020 program. So thank you all for your attention, and don't hesitate to send me your question. Thank you.